All right, welcome back, everyone. Today we're going to talk about exponents. In this section, you're going to learn how to evaluate an exponential expression and how to use the product, power, and quotient rules for exponents. So as we learned from the first chapter, any repeated multiplication of the same number can be written as an exponential expression. So for example, if we multiply 2 times itself 5 times, if we multiply 2 by itself 5 times, then we just get 2 to the 5th power. These two things are equal to each other. 2 to the 5th power just means multiply 2 by itself 5 times. In this case, what we refer to as the base of the exponential expression is the number that's being multiplied. So 2. 2 is the number being multiplied repeatedly. It's called the base. And what we call the exponent is the amount of times that the number is multiplied. So here, 2 to the 5th power means we would multiply the base 2 times itself 5 times. And so 2 times 2 times 2 to the 5th power, that's all going to be equal to 32. So let's just practice using these exponential expressions. Well, 2 to the 3rd power, that's going to tell us to multiply 2 by itself 3 times. And that's going to be equal to 8. In the second problem, 3 to the 1st power, well, that just means we need to multiply 3 by itself once, and so that's just equal to 3. In fact, any number raised to the 1st power will just give you the number back. Well, the examples for C and D here look very similar, but they have very different answers. So for example, for C, we've got negative 4 squared. So that's negative 4 times negative 4. Notice that the negative is within the parentheses, and so the negative is being squared as well. Negative 4 times negative 4 is positive 16. For the second problem, or for part D, the negative is not part of the squared. It's not within the parentheses. So in this case, we have negative 4 squared, or negative 4 times 4. Well, 4 times 4 is 16. And so now we get minus 16. Pay attention to whether the negative sign is within the parentheses and being squared, or if it's outside of the parentheses, because that will change your answer. And then on the final example, we have 2 times 3 squared. We could rewrite this as 2 times 3 times 3, which in this case is going to be 18. Remember that on problems like part E, it's important to use your exponential rules first before you multiply. Remember the order of operations. We could just have easily written this thing as 2 times 3 squared is 3 times 3, which is 2 times 9, which is 18. So let's evaluate some more expressions, but now we're going to be given them in terms of algebraic expressions with x's and y's and such. And we're just going to plug in numbers. So we want to evaluate 2 times x cubed when x is equal to 5. Well, that's 2 times x cubed. That's 2 times, we're going to replace x with 5. Remember exponents before multiplication. 5 to the 3rd power is just 5 times 5 times 5. Or 125, and then 2 times 125 is 250. Remember to always do your exponents before you multiply. For our second example, we've got 9 over x squared. And now we're going to replace x with negative 3. Notice that negative's within the parentheses. It's because x is equal to negative 3. Negative 3 times negative 3 will give us positive 9, and 9 divided by 9 is just 1. It's very important to pay attention to the order of operations when dealing with exponents. Deal with the exponents first, then multiply or divide. So we can perform operations on exponential expressions. If we have two expressions with the same base multiplied together, then the resulting answer can be found by just adding the exponents. So for example, 3 to the 5th times 3 to the 7th, that's just equal to 3 to the 5 plus 7, or 3 to the 12th. And notice that the base doesn't change when you multiply. The only thing changing here is the exponent. So 3 to the 5th times 3 to the 7th. Well, 3 to the 5th is 3 times 3 times 3 times 3 times 3. Times 3 to the 7th is going to be 7 of them. And if you counted all of those up, this is really just 3 multiplied times itself 12 times. And so that's why this rule works. If we had different bases, you couldn't multiply and add their exponents like this. Have to have the same base. So let's try an example. We want to use the product rule to simplify these expressions. Well, we've got x cubed times x to the 5th. When we multiply numbers with the same base, we can add their exponents. That's going to give us x to the 3 plus 5, or just x to the 8th. Similarly, in part B, now remember, if we just have y, that's the same thing as y to the first power. And so that's y cubed times y to the first power, or y to the 3 plus 1, which is just equal to y to the 4th. So if you multiply numbers with the same base, you add their exponents. In the final example, we have x, which is the same thing as x to the first. Now, if we have more than two variables, it still works the same way. If the bases are all the same, we can just add their exponents, 1 plus 4 plus 3. And that's going to give us x to the 8th. So if you multiply numbers with the same base, you add their exponents. It's known as the product rule for exponential expressions. So let's keep practicing this. We're going to use the product rule to simplify this again. Here we have numbers and variables. And so we're going to somewhat treat them separately. If you have numbers in the problem, then perform the operations on the numbers and then multiply the variables. So we have 2 times negative 3. Well, 2 times negative 3 is negative 6. X squared times x to the 5th, that's going to be x to the 2 plus 5, or x to the 7th. For the second example, we're going to get, here we have negative 1, so negative 1 times 3 times a to the 7th times a, so a to the 7th times a to the 1st, times b to the 4th times b to the 9th. Notice we can deal with numbers in each of the variables separately. We're just multiplying all of those pieces together. Well, negative 1 times 3 is just negative 3. A to the 7th times a to the 1st, that's a to the 7 plus 1, or just a to the 8th. And b to the 4th times b to the 9th is b to the 4 plus 9, or b to the 13th. And so our final answer is negative 3, a to the 8th, b to the 13th. And so if you've got numbers involved, multiply the numbers. and then multiply the variables by adding their exponents. So in addition to multiplying exponential expressions, we can also raise them to a power. If an expression is raised to a power, then the resulting exponent can be determined by multiplying the exponents. For example, 7 squared raised to the 5th power, well, that's just 7 to the 2 times 5 power, 7 to the 10th. So what we have here is 7 squared to the 5th. So what we're doing is we're multiplying 7 squared 5 times. So that's 7 squared to the 5th power. Well, each of those has 2 associated with it. 7 times 7. And so on. And so what we're really doing is we're multiplying 7 times itself 10 times, or 7 to the 10th. So when you raise something that's already raised to a power to another power, then you multiply the exponents. So let's practice this. When you use the power rule to simplify, we've got y squared to the 8th power. Well, y squared to the 8th power is the same thing as y to the 2 times 8, because we multiply the exponents. And that gives us y to the 16th. Same thing here. We have x cubed to the 5th power. Well, that's x to the 3 times 5, or x to the 15th. So when you raise a power to a power, you multiply the exponent. So if the product of two variables is raised to a power, then it's like raising each one of them to that power. So 2a to the 3rd power is the same thing as 2 to the 3rd times a to the 3rd, or 8a cubed. And so we're going to use this in the next couple of examples. We're going to simplify each of these expressions. X, y to the 4th power. Well, remember, we can split it up and basically write each one as its own power. So it's x to the 4th times y to the 4th. X to the 4th times y to the 4th, which is just x to the 4th times y to the 4th. When we initially started, each one was raised to the 1st power, and so we're getting x to the 1st to the 4th power, or x to the 1 times 4, which is just 4. Now here in the second example, negative 5x squared y cubed z squared. In the second example, we've got to raise each one of these to the 2nd power. And so we'll get negative 5 squared, x squared squared, y cubed squared, and then z squared. Well, negative 5 squared is negative 5 times negative 5, which is positive 25. X squared to the 2nd power, when we raise a power to a power, we multiply their exponents. So x to the 2 times 2 is just x to the 4th. Y cubed squared is going to be y to the 3 times 2, or y to the 6th. And then z to the 1st squared, which is just going to be z squared. So remember, if you have something in parentheses raised to a power and it's more than just one variable, you can break it up and raise each variable or each number to the power independently, and then multiply all the answers. So if two numbers are divided and then raised to a power, the answer can be found by raising the numerator and the denominator separately. So if we've got a fraction raised to a power, it's the same thing as the numerator raised to that power divided by the denominator. So if something like y over 7 cubed, well, that's y over 7 times y over 7 times y over 7. And y times y times y is y cubed. And 7 times 7 times 7 is 7 cubed. So raising a fraction to a power is the same thing as just raising the numerator and denominator to that power. So let's practice this. We've got ourselves a fraction here. And we want to simplify by raising this thing to some power. So 2x to the 4th over 3y to the 5th to the 4th power. Now we're going to have to break this down based on these rules that we've learned. First of all, since we have a fraction, we know we can separate numerator and denominator. So now the top and bottom's raised to the same power. They're both to the 4th power. And now, because we have something in parentheses, a product, two things multiplied together, raised to a power, we can separate it like we did in the last example. So that we have 2 to the 4th power and x to the 4th power. 3 to the 4th power and y to the 5th to the 4th power. And so if we continue, 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. X to the 4th power, that's the same thing as x to the 4 times 4, which is x to the 16. On the bottom, 3 to the 4th power is just going to be 81. And y to the 5th to the 4th power, since we're raising a power to a power, we multiply their exponents, and so we get y to the 20th. Finally, when we're dealing with the quotient rule, if you have two exponential expressions that are divided, then the resulting exponent can be determined by subtracting the exponents, numerator minus denominator. So if we have something like x to the 6th divided by x squared, it's the same thing as x times x times x, 6 times. And then on the bottom we get x times x. So remember, if we divide a number by itself, we just get 1. X divided by x, it's going to leave us with 1 and 1. And now we're left with 4 x's, or x to the 4th power. So when you divide variables, you subtract their exponents. So let's simplify each of these expressions. X to the 5th divided by x squared. Well, that's the same thing as x to the 5 minus 2, or x cubed. Y to the 7th divided by y, it's y to the 7 minus 1, or y to the 6th. Finally, we have 2x to the 5th y squared over x squared y. Now we've got to deal with each of these separately, numbers and then each of the variables. Well, 2 is just 2 over 1. That's not going to change. X to the 5th divided by x squared, well, that's x to the 5 minus 2. And y squared divided by y is y to the 2 minus 1. And so you get 2x cubed y. So any number raised to the 0 power is always equal to 1, except for 0. You can't raise 0 to the 0 power. So a to the 0 is equal to 1 so long as a is not equal to 0. So let's simplify some of these. Well, 3 to the 0 power, anything to the 0 power is just 1, so 3 to the 0 power is just 1. Similarly, 2 to the 0 power, well, 2 to the 0 plus 8 to the 0. Any number raised to the 0 power is just 1. So 2 to the 0 power is just 1. 8 to the 0 power is just 1. And 1 plus 1 is 2. Finally, 5x to the 0, well, that's 5 times x to the 0 power. Anything raised to the 0 power is just 1, and so 5 times 1 is just 5. So finally, let's take all of these rules that we've learned, and we're going to combine them together in order to be able to simplify these expressions. Here we have 3y to the 7th over 6x to the 5th squared. Remember, we can, because it's a quotient, we can raise top and bottom to the same power. So that's 3y to the 7th squared over 6x to the 5th squared. And now we can raise each one separately. 3 squared, y to the 7th squared. 6 squared, and x to the 5th squared. And if you can recognize what's going to happen, you don't have to take all of these intermediate steps. But 3 squared is just 9. Y to the 7th squared is going to be y to the 14th, right? We raise a power to a power, so we multiply. On the bottom, 6 squared is 36. And then x to the 5th squared is going to give us x to the 10th, 5 times 2. And we're almost finished here. The only thing we can do is reduce the fraction, reduce the numbers. 9 and 36 are both divisible by 3. 9 divided by 3 is 3. 36 divided by 3 is 12. Well, look, they're both still divisible by 3. 3 will go into 3 one time, and it will go into 12 4 times. And so what you're left with is 1y to the 14th over 4x to the 10th. So beware if the fractions, the numbers in the problem, may actually be able to reduce. Don't forget to do that. Now let's deal with the second example. We've got 2a cubed b to the 4th to the 3rd power divided by negative 8 a to the 9th b squared. Well, let's start by first dealing with the numerator. And instead of writing this all out, we're just going to raise each one to the power. So 2 to the 3rd power is going to be 8. A to the 3rd power, that's a to the 3 times 3, which is a to the 9th. B to the 4th to the 3rd power is going to be b to the 4 times 3, which is b to the 12th. And now we're going to divide by what's on the bottom. Negative 8, a to the 9th, b to the 2nd. So let's deal with the numbers first. We've got 8 over negative 8. Then a to the 9th divided by a to the 9th. And b to the 12th divided by b squared. Well, 8 divided by negative 8 is negative 1. A to the 9th divided by a to the 9th, that's a to the 9 minus 9. And then b to the 12 minus 2, which is negative 1, a to the 0, and b to the 10th. Well, we know that anything raised to the 0 power is 1. And you could have seen that before. A to the 9th divided by a to the 9th, any number divided by itself is just 1. And so what we're left with is negative 1 times b to the 10th, or just negative b to the 10th. So as you're working these problems, make sure to keep track of all of the rules and all of your order of operations. So at the end of this lesson, you should be able to identify and evaluate exponential expressions. You should be able to use the product, quotient, and power rules for exponents. You should be able to simplify expressions using the rules for exponents.